log of 18, tell me again. If I say to go to 3 decimal places, what's the 2 going to do to the 5? Right. And so you're done there. Now yesterday we had one that came out to be, once they did the example, the answer was 1. Why did the answer key have that? Right, because it said 3 decimal places, you're expected to, if there is nothing there, to fill the answer with the placeholder 0. Tell me why that's true, do you think? Tell me why you think that might be true. It appears that they're opposite operations, doesn't it? That those bases being matches, if these are true, and I'm telling you they are, if I ask you to convert this guy to exponential, then when you go from log to exponential, you're going to get rid of this guy. Let's see what happens. You keep the base 2, its exponent is x, and it's equal to what's in that position. Does that make common sense on a balance scale? That if you laid 2 to the power of x on this side and 2 to the power of x on this side, that no matter what you put in for x, would it remain balanced? Does that make common sense? Okay. What if I change this guy to exponential format? Start with my base of my natural log. That's my exponent. It's equal to what's in that position. Does that appear to be true? If I laid e to the 4th on this side of the balance scale and e to the 4th there, they would be exactly and perfectly equivalent. Now the problem is 4 and 2 don't match on this. If I tell you that it is true if this equals 2x, do you have any way to change 4 into a number of base 2? Let's do a factor tree. If you had a 4, how could you rewrite 4 with a base 2? Just the 4 part, though. Dylan, how could you rewrite 4 with a base 2? 1 base 2. There you go. I heard it from both sides. Good. So 4 can equally be rewritten as 2 squared. So say I rewrite this little problem without changing it, right? I haven't changed the problem by changing base 4 to 2 squared. Do you agree with me? There's no difference between 4 and 2 squared. Now, Erica, do the bases match? Does the base of the log and the base of that match? So if I tell you that this is true, can we change it to exponent form? 2 to the 2x is going to equal 2 to the 2x, because that position goes here. Is that a true statement? Wait, what, Harrison? It's already an exponent. It was 4 to the x, and then I made 4 into 2 squared, and that's 2 to the 2 to the x. When you have one base and 2 to the 2 to the x, that becomes 2x in the power. Now, is your question about the converting from log to exponential or about the exponent? When you do the conversion up here, you had no problem with me saying 2 to the x equals 2 to the x. And now when we get down here, you don't like 2 to the 2x equals 2 to the 2x? Let's do a couple more, see if it pans out. If it doesn't, I'll try to think of a different way, okay? Give me a couple more examples. What if I gave you an exponential with a log in the exponent position? And what if I told you that that equaled 2x? Like 5. I make my 5 so much like an S, I should draw a line through them, but I don't usually. 5 to the power of log base 5 2x equals 2x. If I tell you that's true, can you convert from that is exponential form, can you take it to log form? My base of my exponent stays the base of my log. My exponent goes here, which was log base 5 of 2x, and my answer goes to this position. Do those create equivalent statements? Tate's shaking his head. Anybody else think yes? They look alike, don't they? They have the same base 5. They have the 2x. Any way to work this that you can think of just the examples from the last 3 minutes? Anything? Okay, Selena says, I can make 9 into a base 3 by saying 9 is equivalent to 3 squared. So Selena says she would make 9 into 3 squared to the x power. 3 to the 2 to the x is the same as 3 to the 2x. We did that in Unit 5 and Unit 6. We're now in Unit 7. If I tell you that this is true, can you convert it to exponential format, Harrison? If I tell you it's true, can you make this guy be exponential format? 3 to the 3x, good, equals what? Oh, shoot, I wrote that wrong. Hold on, guys. Let me fix that. Guys, fix that to 2x. That was my bad. That's my mistake. That's a 2. Is that a true statement? Now, what if I wouldn't have made a mistake? What if I'd have left the 3x there? What would you have had to say about it? False. Good. I did not intend to make up a false one, though. Do you agree that 3 to the 2x equals 3 to the 2x? Okay, good. Today is about just learning how to go back and forth. Monday, the paper you turned in today, on the back of it has a little mini quiz on it of just the conversion. So expect that on Monday, okay? Matching the graph, we've done that in every section. So you have a match the graph section, match the graph section. We are not going to talk about inverses until Monday, so this part right here we're going to leave out for right now. I forgot we had report cards today. I thought we had plenty of time to do the inverse, so we don't. When you look at the problem, let's read this problem together. The level of sound V in decibels with an intensity I can be modeled by that equation. I is intensity in watts per centimeter. Loud music can have an intensity of 10 to the negative 5 watts per centimeter. Find the level of sound of loud music. What am I putting that in for? I, why not V? It told you what to put it in for, didn't it? Like, there's not a question when you get to that last question. It says an intensity of, so it expects you to use that for watts per centimeter of intensity. So don't get freaked out when you get down there and like, oh, this is a hideous question. No, It tells you what to plug it in for. It's just weird looking, and then plug it in. So when you get your paper and you will work, I think we'll get 10 or 12 minutes to work on this. Take a picture with your phone. We will do 1 through 31, not 28 through 30.